Hello everyone, welcome back to Computer Science 252 with Jess Friesma at the University of Wisconsin-Eau Claire. We'll be talking in this mini lecture about program organization design. I should also add errors and warnings because that's kind of the heart of this as well. This covers section 6.1 and through 6.2 in your textbook in a little bit of detail, but also is a lot of other advice from my own personal experience that I hope will be helpful. Variable types. When you're creating variables, always use the most restrictive type possible for a number. So if you've got a whole number and you know that it will always be positive or zero, always prefer to use an unsigned integer rather than a signed integer. So oftentimes for array indices, we'll use an unsigned variable instead of a signed variable. If you know a variable will not possibly be larger than, say, 32,000-ish, you could use a short int rather than a regularly sized long int or an int or a long int. This can help you avoid confusion. It helps remind you and other developers that are working on your code that you expect that this number should be very small, and it can reduce your the memory footprint of your program. However, it might not be as scalable long term, so that's a sort of a weaker piece of advice. It's okay to use the bigger ones. 4 bytes is not going to hurt your program. If you want to represent a conceptually new type of data, use a Typedef. This helps clarify what you're passing back and forth between methods. So, for instance, Typedef unsigned int phone number. Suppose that your method returns a phone number. Maybe the user types it in or something. You could have just returned an unsigned int and have that be the phone number. But if you return it and it's an object of type phone number, even though from the compiler's perspective, it's identical to an unsigned int, however, for the developer's perspective, it makes a lot more sense because it's a lot more readable. It's kind of like self-documenting code. You're returning a phone number object as opposed to an unsigned int that could represent a phone number or a temperature or lots of all kinds of things. So it's something that it helps you understand what's getting passed back and forth. As for writing methods, you want to make as few assumptions as possible about the input parameters. You want to make your code as modular as possible and as standalone as possible. So each method, as far as you can, because sometimes they depend on each other, inevitably, that's what methods do, you want to write methods that will work without having to know how all the other methods work in between. That means that you make it clear for anyone else who uses that code or calls that method what kinds of things are preconditions or assumptions about the input parameters. Make that explicit, so you want to document your code thoroughly, and you also want to check that. So if you're supposed to pass in, say, a pointer to a stack, and that stack is supposed to be a stack that isn't null, check to make sure that that pointer isn't null. Is an integer negative when it should be positive? Check it, and output an error or something if it is. Is the value of a number in the correct range? If you give a temperature as a double, make sure that the temperature is not negative, because that would be impossible, right? If it's absolute Kelvin scale. You also want to make sure that you make clear what units you're using for variables of a scientific nature. You want to make sure that you document your code again. So if there are assumptions that you want to check, list them. List what kind of error you will get if that assumption is violated, or if it won't be checked. On to warnings and errors. Now, a warning I'll define as some kind of message that you want the user to see when they run your program. It's oftentimes like an informational thing. It's not going to kill the program. There's something that's unexpected. It's not quite right. Maybe you want to tell the user, hey, something was a little off. Maybe you want to rerun the program, or maybe you want to try entering a different number or value here or there. But it's not going to kill the program. It might just produce unexpected results. An error, on the other hand, is something that's so severe that you need to kill a program. And so an error message is you basically say, exit, abort, this is something weird happened, this is why, exit, abort, kill the program. But again, both of these are better than letting the operating system kill the program for you. When you do these, you want to make sure that you warn the user when something isn't quite right. If you warn early, you might be able to avoid some other bigger error down the road. Also, if you're checking often, it can help you debug and develop your code a lot more efficiently. It's easy to get, if there's a problem and you don't check it early on, it's easy for that problem to get lost until later, at which point it's really hard, maybe even impossible to detect later on. Not impossible, just really hard. Also, if you check early and often, then it can help you give more information to your user that can help them figure out what went wrong. Also, you don't want to have too many warnings. If you have too many warning messages, then it's easy for the user to be like, I don't have to pay attention to these warnings. And then they stop paying attention to the warnings, and then they get bad results, and they wonder what happened, and it was because they just stopped paying attention. So only give them as many warnings as you really, really need to. If you have too many, maybe you should have some of those be output statements instead. As for warnings and errors, you want to make sure that they're useful both to you as the developer and to your user as the user. So think back to when you were first learning how to program and you had compiler errors and warning messages, and they were not really helpful to you at all because you didn't understand them. Vow to do better than that. You want to make sure that they're useful to both you and to your user. That means you need to give information like maybe the file or the line number to you as the developer, maybe the variable name that was weird. But then you also want to explain what happened so that your user understands how they might do things differently to get it to not have this error next time. The worst possible error, as always, is when your program unexpectedly quits, it was killed by the operating system without any explanation. Because then you have no idea what went wrong, and it's almost impossible to debug unless you recompile and edit your code. Don't let that happen. So again, if you check for errors early and often, you can provide warnings or errors before the operating system kills your program for you. If possible, in errors and warnings, you want to include as many of the following as possible. Try to indicate the severity of the error or warning. Is this a fatal error? Is this a severe warning? Is this an FYI kind of warning? You want to indicate the method and the file, and maybe even the line number that the error was detected in. And remember, if you remember from the previous lecture where we talked about the stages of compilation, you know some ways that you can actually do that. You should also briefly explain what was wrong or unexpected, and say maybe what should have been true. Like, I expected, maybe there was a number that was negative when it should have been positive, and so you say, error, the variable blah, 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 was negative when it should have been positive. That helps you as the developer know, oh, it was this variable, here's what went wrong. And then it tells the user what went wrong, so maybe they'll have a chance to change it next time. Now, if you're writing code for novice users, you might also want to tell the user what to do about it. This is something that a lot of operating systems will do, and some larger software platforms as well, like Microsoft Office. So you might tell them, this is an error, contact your system admin, email the developer with a bug report, give them some kind of actionable item. Let's take an example. Suppose you've written a simple program that lets the user change the computer's clock to a different time. Oh, the power. Suppose you ask the user for some input, give me the hour, give me the minute, give me the second of the day. So the user tries to set the clock by calling set time of day and they enter in 29 for the hour, 1 for the minute, and 36 for the second. This is impossible, and so there should be some kind of error or warning here. What I want you to do is I want you to take a second to pause the video and write out a warning message. If you need to make up some information to make a good warning or error message, do it. But decide, should this be a warning? Should this be an error? And write the message. So pause now, and I'll resume in a moment. Okay, here's what I wrote. Fatal error in set time of day in timezones.c. The user tried to set the time of day to 25:01:36, but this hour was not between 0 and 23. The reason that this is a useful error, and granted, maybe you could catch this earlier. You could say, as soon as the user typed in 29, then you could say, hey, that's not a valid hour. Try again. Type another hour. And then you could keep doing that in a loop until they give you a good value for the hour. But for whatever reason, you got to this method, and that wasn't checked. So again, we're checking again to make sure that everything was okay. So fatal error in set time of day in timezones.c. You're giving them the method, you're giving them the file. I would suggest even giving them the line number. And then the message, the user tried to set the time of day to 25:01:36, being as specific as possible. But this hour was not between 0 and 23. So now it's telling you, the developer, what went wrong, and it's telling the user what they could have done to make it better. Now, for review questions, what should every error message have? What should every warning have? What's the difference between a warning and an error? When should something kill the program or not kill the program? How can I make a warning or error more useful to the user? And how can I make it more useful to the developer? And how can I make it more useful to them both at the same time? Enough information for the developer, but not too much for the user. I encourage you to pause through these, write your answers down, and then continue on. Now for a practice problem, this is a little different than the other practice problems I've done or encourage you to do. I want you to revisit some old code that you've written. It could be for this course, it could be for another course. And I want you to take some of the suggestions from this mini lecture and then try to use those to improve the design of that code that you wrote. And if it's, say, maybe like a single file for like one of our labs or something, like say the stack lab, take, say, 8 minutes to plan and strategize, 8 minutes to document it better, 4 minutes to code it better. Most of the work is going to be in the planning and strategizing stage. Again, those numbers are flexible. Do what is helpful to you. But that'll give you some practice. Look back and forth, especially try to improve the error messages. All right, thank you for your time.